Welcome everyone to part 2 of coordinates and equation of a straight line. Today we are going to start with equation in the form of y equals mx plus c. Here you have to make sure that y must be the subject of your equation. Here mx plus c, m here refers to the gradient as I mentioned earlier in part 1, and c refers to the y-intercept. Simple questions may come like that. Here, y equals 6 minus 1 over 4x. If I'm asking you to get m, and I'm asking you also to get the y-intercept, m here, remember, must be the coefficient of x, which means the number which is multiplied by x. And here, in this case, it is negative 1 over 4. C is the y-intercept, which is the absolute term without any variables, which is what? Which is 6. Over here, if I'm asking you also to get m and c, you have to make y as a subject first. You can't work it out that way. Of course, there are formulas to find it, but I don't want you to memorize anything. So let's make now y subject together. First of all, let's move this here. So 2y equals 6 minus 3x. And now still y is not a subject because it's multiplied by 2. So you have here to divide by 2. Not only here, no, you have to divide the entire equation by 2. And in this case, y equals 3 minus 3 over 2x. Now you can simply say that m is coefficient of x as we agreed before, which is negative 3 over 2. And c, the y-intercept here, is 3. So this is how to get the gradient and the y-intercept from the equation. Next here, how can we get the equation of that straight line? You will have a graph and you will have a straight line drawn in front of you, and you have to write the equation of that straight line. Of course, the first thing should come to your mind is the equation here, which is y equal mx plus c. And you have to understand that your job is finding m, then finding c. How can we find m? You have to choose any 2 points on the graph. Two points which you know for sure without any fractions. For example, me, I'm going to choose this point here and that point over here. The first point we have up here is 0. This color is not okay. 0 and 3. And the second point we have here is negative 1 and 1. Let's write them together here. 0 and 3. Negative 1 and 1. You can find the gradient with 2 ways. Either you use y2 minus y1 over x2 minus x1 as explained in part 1. This is m, this is the gradient. And let's do that together. y2 minus y1 means 1 here. This is y2, 1 minus y1, which is 3, over x2, which is negative 1 minus 0. And in this case, the answer is going to be 2. So our gradient is 2. Or you can simply find the gradient from the graph using rise over run. How can we do that? Here it's easy because over here the grid is clear. So you can simply move up 1 step, then 2 steps. So I'm moving, if you don't understand what we are doing, I am moving from this point to that point over here. And to do that, I'm counting step here. I'm going up from this point. This is 1. This is another point, which is 2. Okay, so the rise is 2. Then we are going to move right 1 step. So 2 over 1, which is 2. Now we got the same answer. So you can use either this way or that way. This is the gradient. About the y-intercept, as I mentioned before, y-intercept is the intersection point with y-axis here, not the point itself, of course, I mean the number. Okay, so the y-intercept is 3, so c equal 3. How can you write the equation? You just replace m and c with the values we got. So y equals mx, m we got with 2, so 2x plus c, which is 3, and this is your equation. And remember, if you are going to use the second way here, rise over run, if you are going left, so it will be negative. If you are going down, it's going to be negative also. Here, let's take a look at this question. Find the equation of a line which passes through these 2 points. Here you don't have a graph and you can't just draw it by yourself. No need to do that. All you have to do is doing these 2 steps. You have to find the gradient, then substitute in the equation to get y-intercept. And now let's do that together. How can we find the gradient here? Here the gradient m equals y2 minus y1 over x2 minus x1, and in this case y2, if you are a beginner and you are doing this, you are not doing this a lot, so it's better for you to write here x1 y1 and here x2 y2. So y2 minus y1, which is 7 minus 4, over x2 minus x1, which is 6 minus 1, and here the equation, this gradient here is going to be, this is 6 minus 5, so the equation here, the gradient of this equation is going to be 3 over 1, which is 3. How can we get the y-intercept? You know that y equals mx plus c. All you have to do now is take this 3 and substitute it here instead of m. So it's going to be y equals 3x plus c. How can we get the value of c? Choose any point of the 2 points provided, this point or that point, and substitute instead of x and y. For example, here I'm going to choose this point over here. So I'm going to substitute y with 4 and x with 5. So 4 equals 3 and x and 5 plus c. So solve this by solving this equation here. So 4 equals 15 plus c. C equals 4 minus 15, and in this case c equals negative 11. Now we have m and also we have c. Write your final answer, which is y equals 3x minus 11. And this will be your final answer over here. Now let's talk about parallel lines. What is so special about parallel lines here? Once you know that 2 lines are parallel, so the first thing you have to know that the gradient of the first line is equal to the gradient of the second line. In other words, m1 equals m2. And in the equation here, in the question, once you see the word parallel, so the first thing you have to do is to get the gradient from the equation you have. Let's take a look at this question here. Find the equation of the line parallel to this. Okay, so here your key word is parallel, and this word here will solve the question for you. Parallel to this equation here and passing through this point. So remember, you are getting the gradient, okay, and this point you are using it to get the y-intercept. Okay, so remember, this is the use of the point. You will substitute as we did in the previous question to get the y-intercept. Let's solve this question together here. To get the gradient, here my equation is 3x minus 4y equals 24. Remember, to get the gradient you have to make y as a subject. You can't work it out like that. So let's make y as a subject together. So this will go there, as you know. So negative 4y equals negative 3x plus 24. Divide by negative 4 to make y a subject. Divide by negative 4, and here also divide by negative 4. So in this case, y equals 3 over 4 minus 3 over 4x minus 6. Now our gradient is 3 over 4. This is m. So m here equals 3 over 4. This is m1, which is equal to m2. Why? Because this is parallel. These are parallel lines. Let's write our equation now. Y equals 3 over 4 x plus c. We got the gradient already. Now it's time to get the y-intercept using the point given to us. And this is the use of the point. I'm going to substitute x and y in my equation here and get the value of c as we did before. Y equals 1 equals 3 over 4 multiply, and instead of x equal negative 4 plus c. So 1 equals, this is negative 3 plus c. In this case, c equals 4. Let's write our final answer here. Y equals 3 over 4 x plus 4. And this is your final answer. Now let's talk about perpendicular lines and the relation between their gradients. Here, as you can see in the picture here, you have two lines. This line A and line B. These two lines here are perpendicular. Perpendicular means they are making a right angle together. Okay, this is the meaning of the word perpendicular. What is the relation between their gradients? Let's find out. Let's get the gradient of A. I will get the gradient of line A. As I told you before, you will choose any 2 points on the line, which you know for sure. For example, I'm going to choose this point and that point. And once I have a grade, the easiest way is rise over run. So this is 1, 2, the rise is 2, over the run is 1. So here the answer is 2. This is the gradient of A. Let's get the gradient of B. The gradient of B here, I'm going to choose also any 2 points on B. For example, I'm going to choose this point over here and that point. How can I move here? You will move up 1 step. This is rise, so 1 over. You will move left 2 steps. When you move left, as I told you before, it's going to be negative, so over negative 2. So this is the gradient of line B. The relation between them is what? M1 multiply M2 equals negative 1. This is the relation between them. We can simply say that they are negative reciprocals, which means if you have M1 equals 2, to get M2 immediately, you can just flip it and change the sign. As you know, this is 2 over 1. You are going to flip it and make it 1 over 2, then change the sign. If it's positive here, so we are going to make it negative. And if it was negative in some other questions, we will make it positive. This is the relation between the gradients of two perpendicular lines. Let's take a look at this question here. Given that y equals 2 over 3x here, y equal 2 over 3x plus 2, determine the equation of the line. So he's asking you to get what? Equation of straight line. Of course, the equation of straight line must come to your mind immediately. Y equals mx plus c. What is our straight line? What do we know about it? He told us perpendicular. So again, this is the key word here in this question. In the previous question, it was parallel, if you remember. That's why we wrote the same gradient. Here, the word is perpendicular. How can we find it? Perpendicular to this line, which is passing through this point. The same thing, this point, we are going to use it to find the y-intercept by substituting. Let's find the gradient we need first. What is M1? M1 is the gradient of the line we have already here. Okay, gradient of this line. What is the gradient of this line? Is 2/3. As I told you up, to get M2, simply it is negative reciprocal. You will flip it and make it 3/2. Then you are going to change the sign to make it negative. Okay, so this is the gradient of the line we need, the new line of our answer. Let's write it in our equation here. Y equal negative 3/2 x plus c. Now our job is to find c, and as usual using the point. I'm going to substitute the values of x and y, then find c. Y here equals 1 equals negative 3/2, x is negative 3, plus c. So then you will solve this equation, simple linear equation. This is going to be 4.5 plus c, and in this case c equals negative 3.5. If you want to write it as a fraction, negative 7/2, it's completely up to you, as you like. All of them are correct. Let's write our final answer here. So y equals negative 3/2 x plus c, which is minus 7/2, and this is your final answer. Now let's take a look at this question, which came a lot before, came many times in the exam. If you have A is a point 4 and 1, B is a point 10 and 15, find the equation of the perpendicular bisector of the line AB. The difference is here, this word bisector. Bisector means passing through the midpoint, which you have to find it first. So the midpoint here, as we mentioned in part 1, you simply add x's together, 4 plus 10/2, and here 1 plus 15/2, which is 4 plus 10 is 14/2 is 7, and here 16/2, this is going to be 8. This is the midpoint. Maybe you are asking yourself now, what is the use of this point? This point here is the point which we are going to substitute to get y-intercept. Okay. Anyway, let's continue. Perpendicular. Perpendicular, as I told you, this is the key word here. You have to get the gradient and then find the negative reciprocal. Let's get the gradient here, which is m1. m1 here is y2 minus y1, which is 15 minus 1 over 10 minus 4. So this is going to be 14/6. After that, you can simplify it, 7/3. In this case, m2 equals its negative reciprocal. You are going to flip it, putting the 3 here and here the 7, then change the sign to make it negative 3/7. This is the gradient of the line you want. Now, as usual, خلاص, this is very systematic step. Y equals mx plus c, which is negative 3/7 x plus c. And again, to find c, we are going to substitute with the midpoint given to us. Y equals 8, negative 3/7 multiplied by 7 plus c. So 8 equals, when you multiply that, it's going to be negative 3 plus c. And from that, c equals 11. And your final answer here is going to be y equals negative 3/7 x plus the value of c, which we got, which is 11, and this is your final answer here. Now let's connect coordinate geometry with vectors. Okay, in March 21 paper 4, students faced this question here. Let's take a look at this question and solve it together. A is the point 7 and 2, B is the point negative 5 and 8. Calculate the length of AB. Calculating length, okay, this is very simple. square root. Here this is x1 y1 and here x2 y2. So x2 minus x1, which is negative 5 minus 7 squared, plus this is brackets here, plus 8 minus 2 squared. This is very much similar to Pythagoras as I explained in part 1. And here the answer you will get on your calculator is going to be 6 square root 5 or 13.42 after rounding. Okay, so your final answer here will be 13.42. Find the equation of the line that is perpendicular to AB and passes through this point. Plus, you know already that passing through the point, you will use this point to get the y-intercept. And here in this question, the key word is perpendicular. So let's get M1, let's get M2, and let's form our equation. M1, which is the gradient of AB, here, y2 minus y1 over x2 minus x1, which is 8 minus 2 over negative 5 minus 7, and in this case the answer is going to be negative half. This is M1. M2 is the negative reciprocal. All you have to do here is just flip it and change the sign. And instead of negative 1 over 2, it's going to be 2 over negative 1. And when you change the sign from negative, you make it positive here. So the answer is 2. This is the gradient which we want. Let's form our equation. Y equals mx plus c. M is 2. So 2x plus c. Now we have to substitute x and y with the values given to us. Negative 1 and 3. So 3 equals 2 multiplying negative 1 plus c. And in this case, c equals 5. Now you can write your final answer here. Y equals 2x plus 5. Let's take a look at question C here. AB is one side of the parallelogram ABCD. Till now the question is normal. Question part A and part B, they are normal questions, and it came hundreds of times before. Let's take a look at question C. AB is one of the sides of the parallelogram ABCD. Of course, when you see a question like that, you must visualize it. You have to sketch a parallelogram here. Okay, and you write ABCD, ABCD. One of the common mistakes here is some students are writing A, B, then here they write C and then D. This is completely wrong. There must be in order, okay, in a rotational order. In any, and if you write it clockwise, it's fine. If you write it anti-clockwise, it's completely fine. So this is a parallelogram ABCD. Let's write our coordinates here. Point A was 7 and 2. Point B is negative 5 and 8. BC, let's read together carefully. BC, and this is BC vector, as you can see. BC is negative A and negative B. What that means? When we say BC as a vector is negative A and negative B, you have to recall what you know about vectors. Up here, up, this is the horizontal change, and down here, this is the vertical change. In our language, which we used this video, horizontal change is run, and the vertical change is rise. And of course, we can use this to get the gradient. We can use this to get what? The gradient. Okay. He told us also, this is what we know about this for now. Let's read the rest of the data. A is greater than 0, B is greater than 0, which means both A and B are positive values. It cannot be negative. The gradient of BC is 1. Gradient of BC is 1, okay, which means the rise over run equals 1. Okay, this can be useful at some point. Here, the magnitude of BC equals 8. If magnitude of BC means the length of BC equals root 8, as you can see. Okay, and the question is asking you to get the coordinates of D. Coordinates of this point is missing. Now let's use the data we have one by one, and let's see how can we use each one of them. I have here BC is negative A over negative A and negative B. The gradient of BC is what? Is 1. Gradient of BC, which means rise over run, equals 1. What is the rise which we have here? Negative B over run, which is negative A, equals 1. Okay, we can form the equation here, cross multiplication, so negative A equals negative B, and from here A equals B. We can't do anything else from this part. خلاص, we know here that A equals B. Okay, what else? Now you are stuck. Well, in the exam, you are sitting down, okay, panicking because you didn't see a question like that before, but you have to know that you have the data, all the data you need to solve this question. We used this. We used this. Okay, and now we are stuck. So what should we do? We have to use that. Magnitude of BC equals root 8. What is the magnitude? From the vectors, okay, magnitude of BC means square root of this part squared plus this part squared. It's the same thing as Pythagoras. So negative A squared is going to be A squared plus B squared. All of that equals what? Root 8. By squaring both sides, we can just cancel the roots. So A squared plus another A squared equals 8. How did I do that? If you here use this A equals B, you can simply substitute B with A. So now it's A squared plus A squared equals 8. And this will make things easier for us because now you can solve the equation to get the value of A. 2A squared equals 8. Okay, dividing by 2 in both sides. So A squared equals 4. By squaring both sides, so A equals positive or negative 4, positive or negative 2. Of course, it's mentioned up that A and B both must be positives. That's why we have to ignore the negative part and just write A equals 2. If A equals 2, so also B equals 2. Now we got the value of A and B. That's great. Now, how can we get coordinates of D? How can this help us finding coordinates of B? Here, BC is this, negative A and negative B. Yeah, which means negative 2 and negative 2 also because A and B both are equal to each other. From the properties of parallelogram here, both sides are parallel. Each two opposite sides are parallel, which means this is also negative 2 and another negative 2 here. This is the vector of that. And this makes things very simple here. To move, that means to move from A to D, you will make -2 and -2. 7 minus 2 is 5. 2 minus 2 is 0. And this is the coordinates. Now let's take a look at another application of connecting coordinate geometry with vectors. The first one here, you know already, find the midpoint of AB. Simply are going to add x coordinates, 4 plus negative 2 over 2, and add y coordinates, which are 6 plus 3 over 2, and in this case the answer is going to be 1 and 4.5. If you want to write it 9 over 2, this is completely fine. Of course, you know that when you find the midpoint here of a and b, so you are finding the point which is in exact midway between a and b. Okay, this is normal. Let's take a look at the second question here. Find coordinates of point P which divides AB in the ratio 2 to 1. How can we do that? We will do that using vectors, but pay attention to me please to understand what that means. I have here point A, I have here point B. Point P, which he wants, is dividing it in the ratio 2 to 1, which means, for example, here, where this part is 2 and this part is 1. This part is 2 parts. 2 parts out of how many parts in total? 2 out of 3. And here 1 out of 3. So from point A to point P here, this is 2/3 of AB, of all of it. Okay, so how can we do that? First of all, let's find vector AB. How can we get vector AB? You will do B minus A, if you know that. So B minus A, which we have here, -2 and 3, minus A, which is 4 and 6. When you do that, it's going to be -6 and -3. This is vector AB. We don't need AB, we just need AP, this one. Now we got AB as a vector. What do we need here? We need this P here. We need to get the coordinates of point B. First of all, we have to get AP, vector AP. AP equals 2/3 of AB. In other words, you can simply write 2 over 3, multiply -6 and -3. And in this case, the answer is going to be -4 and -2. So, mister, is this the final answer? No, this is not your final answer. This is actually the vector AP. What do we need to find now is point P. To get point P, simply you will add coordinates of A to this vector here. What was coordinates of A from the beginning? It was 4 and 6 plus coordinates of B, the vector AP, which is -4 and -2, and here the answer is going to be 0 and 4. So point P here, which divides AB in the ratio 2 to 1, here its coordinates is what? 0 and 4. This question, I didn't see it before in the exams, but I saw it in one of the IGCSE books. So this is an interesting idea. It can come, no problem at all. If you reached that far, that means you liked the video and it was beneficial to you. So please like and subscribe and turn on the bell to get all new videos. Thank you very much for watching and have a nice day.